This is a short video to explain you how to calculate the cost per kWh from a thermal power plant and how do you arrive at the reserve capacity of a plant. For calculating the cost per kWh of electricity generated from a thermal power plant, you need to understand two terms. One is known as the fixed cost and other is called as the variable cost. Fixed cost and variable cost are useful concepts because that actually matters in your arriving at the cost per kWh. Cost per kWh or cost of generating electricity for each unit, right? That is a function of fixed cost and variable cost. Now, what is a fixed cost and how it is calculated? Fixed cost has to do with the initial investment for the power plant. So you know that power plants are hugely capital intensive and lot of money goes into installing the power plant. So typically the values are, let us say around 6 crores is the typical value, which is in 2025 for setting up a coal-based power plant. Okay, so typically 6 crores per megawatt is the cost, and this is known as the capital cost. So if you are setting up, for example, a 100 megawatt power plant, 100 megawatt power plant is to be installed. So this would take up around 600 crores. So this would be the total capital cost, right? Now from this total capital cost, we can calculate the fixed cost. So how do you calculate the fixed cost? For calculating the fixed cost, you need to consider what is known as the interest rate or the cost of capital. So interest rate is decided in the market. Let us say that the interest rate of borrowing this capital from the market is 5%. So this 5% has to be paid every year, 5% of the capital cost. For example, in our problem, 600 crores is the total capital cost, right? So 600 crores is the investment, and for this investment, let us say 5%, so 5 by 100 into 600 crores would be going every year in the form of interest, right? The second thing is in the fixed cost is known as depreciation. Depreciation means the reduction in the value. So because as the power plant ages, as it becomes older, the valuation of that property would reduce. So to account for that, there is something called as depreciation. So let us say that the depreciation is another 5%. So all in all, the fixed cost would be 5 plus 5, that is 10% is your component of interest plus depreciation. And to arrive at the fixed cost, what we'll do is that 10 upon 100 into 600 crores. So around 60 crores would be the fixed cost in this case. So how do you calculate the fixed cost? So for calculating the fixed cost of any power plant, right, what you need to do is that you need to multiply the capital cost with the rate of interest and plus the rate of depreciation. So this, if you multiply, then you will get the fixed cost. There is something called as the variable cost or running cost, which is also to be considered while you calculate the cost per kWh. So variable cost or running cost is because of the salary which is paid to the workers which are working in the power plant. It could be because of the fuel cost. For example, if it is a coal-based power plant, the cost of procuring the fuel and burning it in the power plant, that comes under the fuel cost. There should be some maintenance cost. All this would come under the variable cost, and variable cost would be incurred by the power plant only when the plant is in operation. So variable cost, how do you calculate? You need just add up these components and you will get the total variable cost. Okay, so total variable cost would be typically because of all these three, and fixed cost would be typically because of the capital which is invested and the cost of borrowing this capital and the depreciation of this. Once you calculate the total fixed cost, and the total variable cost, you need to add the two. So total fixed cost plus total running cost or variable cost would be the total cost of generating electricity, right? Now total cost of generating electricity once you get, and if you want to now know what is the cost per unit, then you need to figure out some way how much units of electricity is generated, by that power plant annually, right? All these calculations we generally do annually per year. Now, how do we figure out how many kWh of electricity is generated? For that, there are two other concepts which you need to know. One is known as what is known as the capacity factor, and other is known as the load factor, plant load factor. What is capacity factor? So capacity factor is actually a relationship between how much on an average electricity is generated by that plant upon the electricity which would be generated if the plant is operational at its installed capacity. Okay, so this is the capacity factor. Load factor is slightly different because here also we would in a way compare it with the average demand, but in the denominator we don't take the installed capacity, we instead take the maximum demand, right? At times maximum demand could be equal to the installed capacity, but generally the maximum demand would be lower than the installed capacity. So if a capacity factor is given, right, and the installed capacity is known, one can figure out the average demand. Or if the load factor is given and the maximum demand is known, one can figure out the average demand. So average demand, okay, for a huge power plant would generally be in megawatts, also be in gigawatts, whatever. So if you know the average demand, or if you figure out the average demand, and if you multiply it with the hours of operation, then you will get the units generated. So let us say that megawatts into hours, it would be MWH, or if you want it in kilowatt hours, then what we need to do is that it would be 10 raised to 3 into, suppose this is x times of kWh. Okay, so this way we figure out the units generated. Now units generated from the units or kWh generated from a thermal power plant is not the net unit. It is actually the units which is theoretically generated, but some of the electricity would be consumed by the power plant itself. So that is known as the auxiliary consumption. What is auxiliary consumption? Auxiliary consumption is the electricity which is consumed by the power plant itself. Okay. So how do you figure out then what is the net electricity which is generated? So the net electricity which is generated from the power plant, right, that would be equal to the total kilowatt hour which is generated from the plant minus the auxiliary kilowatt hour which is consumed by the plant. And this net kWh we need to use over here for calculating the rupees per kWh. So how do you then calculate the rupees per kWh? For calculating the rupees per kWh, what you do is that, suppose this is your total C. So this total C, cost of generating electricity, upon the net electricity generated by the power plant would give you rupees per kWh. Okay, so this is how you get the rupees per kWh, right? So this is one part of the problem, that if you are some way able to figure out the fixed cost plus variable cost, and if you are in some way able to figure out how much is the total electricity which is generated, right, and then subtract the auxiliary electricity from it, you will get the net electricity in the denominator, and the cost upon net electricity is rupees kWh. The other useful concept is reserve capacity. And for reserve capacity, it is very simple. Reserve capacity is nothing but the capacity of the power plant greater than its maximum demand. So generally, as I said, the power plant would have a capacity, installed capacity, higher than the maximum demand. So maximum demand has to be subtracted from the installed capacity, and that gives us the reserve capacity. So generally it would be in megawatts or gigawatts, right, for huge power plants. So these two things are supposed to be answered in your numericals. One is how do you calculate the cost per kWh, and how do you calculate the reserve capacity. Okay, if you are able to do this, then you would be in a position to analyze the performance from an economic aspect of the power plant. I hope it is clear to you. Thank you.